All right, good morning, guys. Happy Wednesday. This is that really long day with all the classes. And we have quite a few people out for the PSAT today. I know in my Algebra 2 classes, not so much in my Precalculus classes. I'm going to be making the same announcement today and tomorrow, and that's if you have a failing grade right now, let me encourage you to talk to me, please. Because I never want you to feel like it's too late. You know, it's like I'm failing and there's no hope. And no. There's always hope. When you're dead, there's no hope. When you're dead, it's over. You can't fix your grade. But I know you guys are alive and willing. And if you do care about your grade at all, you should talk to me so we can take a look at things and have a plan. I always want you to feel like there's hope. Okay, because why bother if there's no hope? We could be kicking back at the park or, playing Xbox or something, So we always want to have hope, that we can improve. And I want you guys to always feel like you can improve, okay? So I do have like over 100 students. So I need to know that you care, so if you do care about your grade, send me a remind message, and let's set something up and put a plan together. You know what I mean? So let me know that you care. And I obviously care because I stand up here every day and teach. So I could do this a lot easier ways for me. I could do one video and run it for 5 classes that I'm here every day teaching. So you must know that I care about you. Okay. I started lesson 1.7 yesterday, and I didn't want to throw too much at you. So today I'm gonna finish the lesson. But before I do, I want to look at some more of the complicated problems. Can you do me a favor? Look on page 258. Okay, on page 258, problems 1 through 30. They didn't want you to graph. They don't want you to solve. They don't want you to evaluate. All they want is the domain. And the domain is where the graph exists, left and right. So if you can recognize the line, it exists forever, left and right. If you can recognize the quadratic, it exists forever, left and right, whether it's up or down. It doesn't matter where it is in the coordinate plane. If you have a quadratic up or down, the domain is forever left and right. Now, if you had a sideways quadratic, the domain is not forever left and right, but we're not dealing with that right now. That's when you have a y squared and an x. We're only dealing with parabolas up and down. Okay, if you have absolute value, the domain is forever left and right. If you have a cube root, the domain is forever left and right. However, if you have a square root, you cannot have a negative under a radical, because if you do, it's imaginary. So a square root goes off to the right because you cannot have a negative under a radical. Square root. You can have a negative under a cube root because you're guaranteed one real solution under an odd index, but you cannot have an even index like 2, 4, 6. I take it back. You can't have an odd index under a square root and have a real number. So you cannot have a negative under an index that's even 2, 4, 6. Now, some of these other problems I didn't address because I didn't want to throw too much at you. So I want to do a couple of those problems right now, some more complicated problems for domain. So I want to do problem number 14. this is a complex fraction. And this is a rational equation, which means it exists everywhere except where you get a 0 in the denominator. So let me show you how to do this without graphing, without doing anything. Let me show you how to do this. All right. You're concerned about two fractions. So see this little fraction right here? You can't have a 0 in the denominator. So right away, you can say x cannot be 0. So that is an excluded value. And then you have this big fraction, which means that this whole thing cannot be a 0. So what we do is we set it equal to 0 to find out the excluded value. Now, somebody last period said, Ms. Birch, you always set it equal to 0. Well, look, remember when we had easy problems like this and we said x cannot be 3? Remember when we had easy problems like this and I said, what makes a 0 in the denominator? You said x cannot be -4. What we were actually doing is we were setting it equal to 0 and solving for x. So that's why x cannot be 3. When you take x plus 4 and set it equal to 0, you get x is equal to -4. So that's what we're actually doing. So back over here, when we set it equal to 0, we're going to solve for x and find out what we need to exclude. So if I multiply both sides by x, I get 4 equals x, which means x cannot be 4. And you might have already been able to see that because 4 over 4 is 1 and 1 minus 1 is 0, right? If x is 4, 4 over 4 is 1 minus 1 is 0. So yesterday I showed you how to figure out the domain on the number line. So I want to take a look at it again. So you cannot have 0 and you cannot have 4 because those are the two numbers that give a 0 in the denominator, either at the little fraction or the big fraction. So we know that the domain is everything but those guys. So this is what we really want to represent in interval notation. So how do we represent it? Well, we say negative infinity up to 0 open, don't include it. 0 to 4 open, don't include the 4. And then 4 to infinity, which is the colored in arrow. So that's how we would represent the domain. So if you're trying to find out what makes something 0, set it equal to 0 and solve for x, and that would show you the excluded value that you need to throw out. All right, does anybody want to ask me a question about this right now? We're going to do another one. But would you like to ask me about it now? Is anybody confused about what I did? Let's try another one. Let's try another one. Let's look at another one. Let's look at 16. Another complex fraction. This one's worse. It's 1 divided by, what is it, 4 over x minus 2 minus 3. Yeah?
Yeah.
Okay, so let's take a look at the little fraction first. So you can just look at that and tell me, what makes that 0? And if you can't figure it out, take x minus 2 and set it equal to 0. But you could probably just look at it and tell me. Go ahead. What makes that 0?
2.
That's right. X cannot be 2 because 2 minus 2 is 0. So that took care of the little fraction. So now we look at the big fraction. This is more complicated, right? Because what we have to do is we have to take 4 over x minus 2 minus 3 and set it equal to 0. Because I don't know about you, but it's not totally obvious to me what it is. So I'm going to solve for x. So you add 3. And now what I'm going to do is I'm going to put that 3 over 1 and I'm going to cross multiply because I have a proportion. So this is going to be 3 times x minus 2 equals 4 times 1. So when I distribute, I get 3x minus 6 is equal to 4. Can you guys see the board still?
Yeah.
So when you add 6, you get 10, and x equals 10/3. Now, I would have never come up with that just guessing. Like, it was easy to see that x cannot be 2, but to find out what that has to be to get a 0, right? 1 over 0, I couldn't sit there and guess. So therefore, we just set it equal to 0, and now we know we have to throw out 10/3. So let's draw our number line again to help us out. And we know where 2 is, but where is 10/3? Well, isn't 10/3 3 1/3? So isn't it over here somewhere? I'm gonna write it like that. Doesn't matter where it is exactly. You just want to know it's to the right of 2. So these guys have to be open, and we have to include everybody else. So what would your domain then be? It would be negative infinity up to 2 open. And I'm not going to put 3 1/3. I'm going to put 10/3 or 10/3 to infinity. So it's not so bad if you understand what you're trying to do. Any questions about this?
Can
So
you
do we have to make the equation equal to 0 in that third part?
Say that again.
That 0 so we have to turn an equation that equals 0?
Yeah, the first thing you're gonna do is look at the little fraction. So the little fraction, you could just look at this and go, what makes a 0 in the denominator? 2. So 2 has to be thrown out. And then you're gonna look at the big fraction and say, what does this stuff have to be to get a 0 in the denominator? So you're gonna set it equal to 0. So the first part is that little tiny fraction right there. And this part is the big fraction. So you can't have a 0 here, and you can't have a 0 under the big fraction.
Okay.
Victor, do you get what I'm saying or no? Am I just really confusing right now?
Yeah, I get it.
You do? Okay. Do you guys want to do another problem just to make sure or not?
Yeah.
Okay, let's do another one. Let's do one of your problems. You want to do 13 or 15? You pick.
13.
Okay. Okay, now, obviously, the more of these you do, the more confidence you're going to have. This is not the easiest thing in the world, but I think if you conceptually know what you're trying to do, it will help. So let's look at 13. Why is this board twisting so much? Okay, so 13 is h of x. It's what, 4 over 3 over x minus 1. So what we're not going to do is panic and give up. We're going to tackle this with all of our might. All right, so look. There's a little tiny fraction right there. So what's going to give us 0 in the denominator for just a little fraction? What number is going to give us 0 right there for that? Don't look at anything else. Just that little fraction right there.
Negative x.
3.
Okay, wait a second. Wait. Okay. We're focusing on this only. So if you are focusing on this only, nothing else, give me a number. You guys are helping me out, by the way, with your responses. You're showing me how horrible of a teacher I am. All right. It's a good thing. It's a good thing. It'll just make me better. Okay. What number do you have to put there to get a 0?
0.
Right. Exactly. 0. So the first excluded value is 0. Good. Okay, now we're going to look at just this. Now, Mark or somebody said x can't be a 3, right? Because you notice that if that's a 3, 1 minus 1 is 0, and you're right. But let's say you didn't see that. What you could do is you could take 3 over x minus 1 and set it equal to 0 and solve for x. And we could find out that x, can you guys see? X cannot be 3. So when we write the domain, we would go negative infinity up to 0, keep it open because you can't have a 0. And then 0 up to 3, keep it open because you can't have a 3. And then 3 to infinity. So was it better that time around? When you look at 3 over x only, can't have a 0 there. And then when you look at that thing, you set it equal to 0 and find out what else you can't have. Does that help or no?
Yeah, for me it is.
Yeah.
Oh, you guys are so sweet. You're like, no, Miss Birch, you are confusing. You just don't want to tell me that. That is the best I've ever taught it, but that doesn't mean that it was good. So I gave it a good shot. You guys are going to have to just ask me or just meet with me and I could keep trying to explain it better. You just can't have a 0 in any fraction, whether it's a little fraction or a big fraction. Can't have any zeros in the denominators. That's the main thing. Okay, now yesterday, I talked about this domain thing. You don't have to graph, you do not have to solve, you don't have to evaluate, just you have this, the domain is where the graph, you're stating where the graph exists left and right. Okay, I also talked about combining functions, adding, subtracting, multiplying, and dividing, which I hope seemed fairly simple. But today, we're going to talk about compositions. And in high school, I was really confused about this. I was confused so much that I made it a goal of mine to teach this as good as possible. So I'm hoping that I can teach this really good today so that you're not confused like I was in high school, but this was really confusing to me. I just couldn't get it. This is objective 3, and it's composite function. So it's going to look like this. That is not multiplication, by the way. That little open circle means a composition. And sometimes you'll see it written like this, which is really confusing to me. So this means this. And when you read this, this does not mean F times G. It means it's read as F of G of X. So it's read as F of G of X. So basically what they're going to do is they're going to give you two functions. So they're going to say, okay, given a line and another function G, this is a quadratic. So given that, we want you to find this composition. Now, if you're wondering why are we doing this, this is part of something bigger called inverses. We're going to do inverses in the next, coming up in the future, and you're going to need to know how to do a composition to not find inverses, but to verify or prove inverses. So just hang in there and just try to learn this, okay? So the first thing I would do is write it in the way we understand it as F of G of X. So what we're going to do, you guys, is we're going to work from the inside out. So you're going to drop down the F and put the G function in. So the G function is x squared minus 2x plus 6. Okay, now, those of you who are familiar with baseball, you have a starting pitcher and you have a reliever. Well, we're looking at the F function now. This is F of X. F of X. So the starting X in F was X. We're going to take him out. That's the F function, right? We're going to take the starting pitcher out and we're going to put the reliever in, which is x squared minus 2x plus 6. So let me just review what I did really quick. We're working from the inside out, and what I did is I brought down the F and I put the G function in place of G of X. This becomes the X of the F function, which is 3 times something minus 4. And the something now is this new pitcher. And now we just do the problem. So this would be 3x squared minus 6x when you distribute, minus 4. So your answer is 3x squared minus 6x plus 14. You want to ask me about it, or you want me to do another one?
So you replaced F with 3 because it was 3 times something minus 4.
Okay, so the first step is I took the G of X out and I put the function in its place. Now what I have is F of X. So this is F of X. So what I did is I wrote down the F function without that X and I put this X in its place. So I substituted this in for X.
Oh, okay.
See, this right here used to be a plain X, but I took it out and I put this new guy in.
All right, I got it.
Let's try another one. Let's try another one. Okay, so I failed on that one. So I'm going to try another one. So they might switch it up. So they may write this, g of f of x. And you're going to work from the inside out. So you're going to put the f function in. This time the f function is 3x minus 4. Right? So this says g of x. G of x. Well, we're looking at the g function. So wherever you see an x, you have to take it out. So see, I took the g function, I took the x's out, and we're going to put, so this was the starting picture. We're putting the new guy in for x. Follow me?
Yeah.
All right, so this is a long problem. We have to take 3x minus 4 times 3x minus 4 in FOIL. I see that? Minus the distributive property, minus 6x plus 8, a negative times a negative, plus 6. FOIL would be first, you're multiplying, outer, inner, last, and then you combine all the like terms. So this would be 9x squared in standard form, a negative and a negative is negative 24, and a negative 6 is negative 30x. And then 16 plus 14 is 30. Now, let me ask you a question. Can we divide by 3?
Yeah.
Yeah.
Okay, that's what first period said, but let's think about this for a second. Is this an equation? Like if I divide by 3, can I divide by 3 on the left side? So is this showing something like this? Where I can divide both sides by 3? Is this an equation? Or is this an equation?
The bottom one's an equation.
Right. The bottom one we can divide by 3, but we cannot divide an expression by 3. If you divide by 3, you just messed up the answer. So that's an expression, that is not an equation. Okay, let's try a few more. Now, like I said, it's important that you get this because we're going to be using this for something else. They could even do this, you guys. They could do f of x. So we work from the inside out, put the f down. The f function is 3x minus 4. This is going to be our new our new x for the f function. The f function is 3 times x minus 4. 3 times something, right? Minus 4. So we take that x out and put this in. And our final answer would be, well, not quite. 9x minus 12 minus 4 is what? 9x minus 16? So just remember, you work from the inside out. So you put the f function in. This becomes f of x. So now you're going to take out the starting x and put in your new x, 3x minus 4, and combine like terms, or distribute, or FOIL, or whatever you need to do. Do you have a question about this or no?
No.
All right, guys. The next objective is finding the domains of compositions. So I'm going to try my best on this one. Let me write down the objective. Finding domains of composite functions. All right, so in this example, they give you a function which is rational, and they give you the g function which is also rational, 3 over x. And the first thing they want you to do is find the composition. So they want us to do this. And we know what this means. It means f of g of x. And we're going to find the composition. So we're going to work from the inside out. We put in the g function. That becomes the x of the f function. So, excuse me, what is the f function? It's 2 over something minus 1. And the something now is 3 over x. So, like we did in the prerequisite section, I told you to treat a complex fraction as 2 separate problems. So remember how we did this? We got a common denominator on the bottom. And we ended up with 2 divided by, the common denominator is x, and this would be 3 minus x. Now remember, you cannot cancel parts of the sum or difference. And once you get it simplified on the top and the bottom, lay the stack out flat. So what you have here is 2 divided by 3 minus x over x. And remember what we do? We change it to multiply and take the reciprocal. So we're done. Our composition is 2x over 3 minus x. That's the composition. Now here's the hard part. We have to find the domain. And I'm going to try to explain this as well as I can here. In this entire problem, you do not see this. Therefore, 1 doesn't matter because you don't see this in this problem, so throwing out 1 doesn't matter. What matters is this. What we did before. Remember that you can't see this little fraction right here? Can you guys see it or no? Can't have a 0 here, right? So we know that from that, x cannot be 0. All right, so I'll write it over here. So for the little fraction, x cannot be 0. And then what we have to do is we have to take 3 over x minus 1 and set it equal to 0 to deal with the big fraction. Because you can't have a 0 under the big fraction either. Let's see this over here. So I'm going to solve for x. So 3 over x equals 1. You can multiply both sides by x. X is equal to 3. So x cannot be 3. And Mark, you probably already saw that because 3 over 3 is 1 minus 1 is 0. So you cannot have a 0 here. And under the big one, you cannot have a 0. So if that's a 3 over 3 minus 1 is also a 0 under the big fraction. So the domain then is negative infinity up to 0, 0 up to 3, and 3. So that's the domain of the composition. At least we're having fun, right? All right. I'm going to do the last objective, and then we can come back and do another problem like this if you want. This is the section where you have to find a composition and then find the domain of the composition. So it is requiring that you know how to simplify complex fractions. Now, this last thing is easy. Hope if I can explain it good. It's really super easy. And objective 5 is writing functions as compositions. So check this out. It says to express h of x as the composition of two functions. And they're going to give you h of x. So this is easy, guys. This is easy. Stay with me. They want us to go backwards. So they want us to come up with the two functions that give the composition h. I know this is going to seem crazy, but I'm going to teach it really good. So I'm going to say it again. This is the composition. They're giving us the result, and they want us to find the two functions that give the composition. So now, instead of going from the inside out, we're going to go from the outside in because we're working backwards. So if we look at the main skeleton of this, the main skeleton is the cube root of x. And what's inside is x squared plus 1. And that is the answer. And I'm going to prove to you that this is right. So I'm going to do the composition and show you that it works. So G is x squared plus 1. That becomes the x of the f function, which is the cube root of x. And now he gets, so see how it equals h of x? Okay, that is the lesson. I am done, but I want to work a couple more of these just to prove to you these are really easy. All right, let's do problem number, this is at the end of the assignment. Let's do problem number 80. So number 80 has h of x being the absolute value of 3x minus 4. Okay. They want us to come up with the f function and the g function that gives h as the composition. So instead of working from the inside out, we're going to go from the outside in. So f is going to be the skeleton or the outside, and the outside is the absolute value of x. And what's inside is 3x minus 4, and that is the answer. And I'm going to prove to you by finding the composition that we're right. So the g function is 3x minus 4, and that becomes the x of the f function, which is absolute value of x. Take the x out. So when you're trying to find the two functions that create the composition, do not work from the inside out, go from the outside in. Okay, does anybody want me to work another problem of some kind? I don't think I could probably work another one of these if you want. I think that's all we'll have time for. Would you like me to work another one of these?
Yeah.
Okay, let's do 76. All right. So in 76, they give h of x is equal to 2x minus 5 quantity cubed. Okay, they want us to write the two functions. They give the composition h, and instead of working from the inside out to find a composition, we work from the outside in. So outside would be the cube. It's the parent, right? So if you notice in the last problem, it was absolute value of x, which is the parent. So this is the parent. And then the inside would be 2x minus 5. So to prove this, we do the composition f of g of x, and we put the g function in, which is 2x minus 5. That becomes the x of the f function, which is a cubic 2x. So this is just a check. So I'm just showing you how to check it. This is the answer over here. So I think it's safe to say that when you write f, it's some type of parent. It's either x squared, x cubed, cube root of x, or root of x, absolute value of x. It's the parent of what you see. It's the function, it's the parent, and then g of x is what's inside the parent. All right, you guys, that is the lesson for today. Thanks for hanging in there with me. If you're confused about something, you should be. Just look at your notes. So I'm giving you really good notes, or you can contact a classmate. We're going to spend some time on this tomorrow. There's 5 objectives that I've gone over, and we're going to spend some time looking at them. Okay? In our teams. All right, you guys have a great day, okay? And I'll see you tomorrow. All right, you guys have a good day.